Alright everyone, welcome to 4.1 examples. Describe the antiderivative of, or I should say antiderivatives of 3x. As there are an infinite amount of them, we need just to find one big idea of how to do them, and then we can just say plus c and then we'll be done. Alright, so we're going to basically try and find the derivative of 3x dx, which means we can also write this as 3 integral of x dx. Alright. Okay, so that means that what we ended with, our slope is going to be x, which means we probably had to go down a power, so it should probably be something with x squared. Alright, but if I have x squared, that means that 2 goes out in front, which means it has to be 2 times something. I have to end up with 1, so it's got to be a 1 over 2, 1/2, right? Because if I take 2 times 1/2, I'm going to get a 1x, and I'll get 1x dx. Okay, so we'd have that times 3. Alright, so now if I were just to rewrite this, I could say this is 3 over 2x squared. Okay, that is one possible answer. Unfortunately, it's not the only one, and we have a whole bunch more that we could do. So instead of just writing it like that, why don't we write out plus c? That way we can say plus any number, and then we basically have it all done. I would suggest writing that plus c right here so you don't forget it. Alright, that way we have our solution. So it would be 3 over 2x squared plus c. Alright, here is our next example. The integral of 1 over x cubed dx. Well, we can rewrite this as x to the negative third dx, and then have the integral right here. Alright, x to the negative third. So that means I have to go down 1 power, right? So it's going to be x to the negative second. Okay, right? And then I also have to make sure that when I multiply this, it kind of cancels something out. So I have to have negative 2 times something to cancel out to a negative 1. So it should be negative 1 over 2. So I should have negative 1/2 x squared, or x to the negative second. And if I would want to rewrite this one, I'll probably write the plus c right on there. Okay, and then I'd probably just rewrite this as 1 over, let's just make a negative out in front, 2x squared plus c. Alright, those two are the same thing. I'm going to write it like that, so that way it looks all nice and pretty. Okay, part B. We're going to say this is the integral as x to the 1/2 dx. Alright, so we're just kind of rewriting these as, with different, okay, yep, good. Alright, so we can rewrite this as x to the 1/2. That means I can still do the same thing. So if I add 1 power is basically the idea, it should be 3/2, right? So I should have x to the 3/2, because if I take the derivative of this, it should be to the 1/2, and I have to get rid of multiplying by 3/2, so it should be 2/3. And then I can do plus c. Alright, and then if I want to rewrite that, I could, but you know what? I'm just going to leave it just like that. So maybe I can write it a little bit bigger. It might be a little hard to see there for you. So it is 2/3 x to the 3/2 plus c. Alright, 2/3 x to the 3/2 plus c. Unfortunately, doesn't seem to be focusing very well for you. Sorry about that. Alright, and part C, the integral of 2 sine x dx. Well, first we can write this. We don't have to worry about that 2. That can just kind of go out in front. We can say that's an integral of 2 sine x dx. Alright, and so what trig function, when you take the derivative, equals sine x? And you should remember that that is going to be 2 times negative cosine x. Alright, and I kind of ran out of room here. I think I could just write it as an equal sign. I like the arrows because that way, ding. So I can write it like that, and then don't forget to plus c. So I could write negative 2 cosine x plus c should be my solution there. Alright, so there's a few examples. Let's do just a few more. Here's example 3, the integral of just dx. Okay, well that's really the same as the integral of 1 dx. Okay, and then you say, well, what's that? Well, that's just the same as x plus c. Alright, good. Let's do x plus 2 dx. That we can actually just rewrite as the integral of x plus the integral of 2. Don't forget your dx's. Alright, So it's the integral of x dx plus the integral of 2 dx. So what's the integral of x? Well, that's just going to be the same as 1/2 x squared. And what's the integral of 2? Well, it's really going to be the integral of 2 times that thing, so it's just going to be 2x. And then don't forget your plus c at the end. Now I could do like a plus c here and a plus c here, but because it's just c is just some constant number, we can combine those c's and not say it's 2c, but we can just say this is 1/2 x squared plus 2x plus c. We can just do that plus c just the one time. It doesn't matter. We don't have to say plus 2c because it's just some constant. 2c would be the same as 5c or 10c or whatever because we can just pick any number for c. All right, there you go. So it should be 1/2 x squared plus 2x plus c. All right, and then here's another example. The integral of 3x to the 4th minus 5x squared plus x dx. All right, well, let's try this. First, that's just the integral of 3x to the 4th plus the integral of negative 5x squared plus the integral of x, and then we have dx's for all of them. If you want to write them in right away, that's okay. I kind of just forgot to write them in. Not a big deal. All right, so now let's try to do that. Well, this one is going to be x to the 5th, and I have to divide by 5, so it should be 3 over 5, the 3 coming from here, and then the 5 coming from what my integral is. That way I'm ending up with a 3. Okay, and then I can do plus c, and then I can do negative 5 over 3x to the 3rd plus c, and then I can say this is 1/2 x squared plus c. All right, now I'm just going to kind of clean this up just a little bit more. Keep my highest exponents. I have them in the correct order, so I'm just going to rewrite this. Hopefully you can see this one. 3/5 x to the 5th minus 5/3 x to the 3rd plus 1/2 x squared. And then don't forget that plus c at the end. It's only 1 plus c. All right, and here is, I believe, your last and final example on antiderivatives. So this is the integral of sine x over cosine squared x dx. All right, so what we're going to do first is let's just maybe make this a little bit easier and say this is 1 over cosine x times sine x over cosine x. And let's just say that's dx. All right, so from here, I can rewrite this as this is the integral of 1 over cosine is really just secant x, and sine over cosine is just tangent x. So I can say this is secant x tan x dx. All right, so then we can go back to that chart on page 243. You can say, do I see any secant x tangent x that's already on there? And if you look to like the second to last one on the right side, oh, look at that. Integral of secant x tan x dx equals secant x plus c. So we can just say this is secant x plus c. All right, so I can go through a whole bunch more stuff and make it really more complicated, but I really don't want to. So there you go. There is a bunch of examples on how to do these integration rules and just doing some antiderivatives. Good luck.